Good evening, everyone. Welcome to the Carolina Weather Group. We're happy to have you this evening and hope your day has been good. And we're looking forward to our conversation tonight with Miss Meghan Herbst. She is a research editor for Wired, and we're going to be talking about hurricanes and satellites and a new project that's being launched to help track these hurricanes. And hopefully the end result will be better forecasting. So looking forward to that. Meghan also has a really cool weather story herself. So we're going to ask her about it. Meghan, welcome to the show. I know you are a journalist right now for Wired, but you've not always been with the organization. So tell us a little bit about your history. We call this the weather journey, and you actually do have a little bit of a weather journey. So welcome to the show. Introduce yourself to everyone and let us know a little bit about your weather journey that you've been on that's led you to writing this article.
Yeah. Thanks for having me. And just a little bit about my weather background. I started out in the U.S. Air Force as a weather forecaster. I served for about 4 years, and in the Air Force, to become a weather forecaster, you go through an 8-month intensive training school and receive kind of like all of the same atmospheric physics and meteorology education that you would for a bachelor's degree, minus some of the higher maths and all of the extra curriculars that you might have when earning a degree. But
which I'm sure you're not. I'm sure you're not sad that you had to miss all those math classes. Right?
Definitely not. It's still kind of a goal to one day maybe go and finish up the degree by getting those upper math classes, but we'll see. Maybe down the road.
I was intimidated by the upper math classes. I did the minor and not the full degree, and I'm sure Frank's sitting over there probably wagging his finger at me. But I was intimidated by the upper math classes.
Math, we don't like math around here. So.
It's understandable that you would be afraid of the math. I don't know how I made a B in differential equations. I still consider them to be magic. So
Could you do it today though, Frank, if you took that test?
Actually, I think I would probably do better today because I have a better understanding of it because of the theoretical meteorology that I studied. I think I'd probably do better today than I did when I was in college.
All right, we didn't mean to steal your answer there, Meghan. Go ahead.
No,
we'll let you
I'm
continue.
very jealous of that math knowledge. But from there, I went to my first duty station, which was in Hawaii at Hickam Air Force Base. Now Hickam Pearl Harbor is a joint base. But there I spent about 3 years forecasting for a whole bunch of locations in the tropics, including Okinawa, Kadena Air Base on Okinawa in Japan, Diego Garcia, which is a tiny little atoll in the middle of the Indian Ocean. A couple other locations like Wake Island in the Philippines, and kind of supported our pilots with weather briefings, did forecasts for the bases, and also some upper air hazard charts for turbulence and icing for our pilots. So that was the beginning of my weather journey and kind of the end for a while. I did go into journalism after I separated from the military and spent about 5 years earning a bachelor's and master's degree in journalism. And then luckily landed a pretty sweet gig at Wired and have been there since.
We were talking before the show tonight, kind of weather and space is your alley. I mean, you get to still be involved in writing these articles about weather and space, which I'm sure really excites you because you've already had that passion for weather.
Right. Yeah. I'm always looking for a good weather story, which is how I happened upon this one in particular. And yeah, it's always exciting to dig back into my weather knowledge and bring some, more clarity to the subject for readers.
Well, let's talk about this one, Meghan, and let's just first bring our viewers and listeners up to speed. If you could summarize this a little bit, you wrote in June for Wired. We have a link to the article right now in the description of our show here about these tiny satellites that some of which have been launched, some of them to come, that are going to help us with forecasting the tropics. How does this all work?
This is the TROPICS nanosat constellation. And it's basically a constellation of 7 nanosatellites. And nanosatellites are very small satellites. They weigh between 1 and 10 kilograms, so about 2 to 22 pounds. So we're talking really small, lightweight satellites that are going to be launched in a particular orbital configuration around the Earth that will allow for them to offer kind of an unprecedented refresh rate for the data that we're able to get over the tropical region.
As a journalist, Meghan, I'm curious, and we'll talk more about the specifics of this program in just a moment, but how did you come across this story?
So I was actually just digging into the whole nanosatellite area. I was really interested in all these, really interesting scientific projects that are just kind of getting attached to nanosatellites and shot up into the atmosphere. But I was talking to an aerospace engineer at MIT about a CubeSat that she was using to test out a new type of mirror that could allow us to see very small exoplanets around distant stars. And I just asked her, are there any other really cool satellite projects that you're working on right now? And some of her graduate students were working on the payload for the TROPICS project. And she told me it was this weather project out of the MIT Lincoln Lab that was going to put weather sensors and microwave radiometers on tiny CubeSats. And it was funded by NASA, already developed and built, and was just waiting to find a launch provider. So I jumped on that because it had a good, weather kick to it, and found out that it was a really interesting project.
Hearing about this project and seeing that NOAA, NASA, and all these organizations are working with it, how did you approach out? How did you reach out to these folks and saying, hey, I'm interested about what you guys are working on?
So luckily the name of Wired carries a lot of weight. And so I just emailed the project lead, Bill Blackwell, at MIT Lincoln Lab, and told him I'd heard about what he was doing with TROPICS from a colleague of his, and set up an interview to talk about it. And pretty quickly I realized it was this really interesting and unprecedented kind of satellite array that could give us a lot more accurate data at a faster clip. And a couple of years ago, I had actually written a story about the psychological toll and stress that forecasting for these major hurricanes in hurricane-prone areas was having on weather forecasters. And so, hurricanes appearing to become more frequent and intense kind of hit me that something like this could have a significant impact on not only the forecast, but the ability for forecasters to put out timely warnings and kind of help the people in their communities.
So let's talk about this project. From what I understand, when you wrote this in June, the launch, they were getting ready to launch these. So can you tell us a little bit about that? What all went into this launch, and really there's two steps. So this first launch was, I guess, to kind of lay the foundation down. So can you tell us a little bit about what has already taken place and what we're looking forward to in the months and year to come?
So on June 30th, they launched this first unit, which is they're calling the Pathfinder unit. It's basically an engineering qualification unit. It's going to test out all the computer systems and their data processing systems and just make sure everything's operating well before they launch the next 6 satellites in the array in the early half of 2022. And right now, the first launch is scheduled for January 2022. So that launch will contain 2 of these CubeSats, which will be put into orbit at a just 30-degree inclination to the equator. So just covering a swath of the tropics.
Is there any worries about what is to come from this? I mean, I think we're testing things out now. Have you learned, or have you been able to follow up and see how the tests have went so far?
I checked with Bill Blackwell just the other day, and he said that everything is going really well so far. All their systems are working as expected, and they were actually able to get some images of Hurricane Ida as it made landfall in Louisiana on August 28th and 29th. And they were able to use a brand new channel at the 205 gigahertz wavelength that could see more into the ice crystals forming, precipitation-sized ice crystals at the top of clouds, just to take a look at how they're hoping to take a look at how storms are intensifying.
And Megan, if you could help some of our viewers and listeners understand, we have different types of satellites that are out there, geostationary, these polar orbiting ones, and these almost remind me of some of the like the SpaceX kind of internet ones, right? Where they're in a train. Can you paint a picture for us to help us explain why these satellites are able to see things that others can't?
That's a good point. That we have two different major types of weather satellites: the geostationary orbiters and the polar orbiters. And geostationary orbiters kind of fixate on a particular part of the globe and stay there, and the polar orbiters obviously orbit the poles and give us different slices of the longitude of the Earth. But the refresh rate for how often we're able to see a particular slice of the Earth for those can be anywhere from 12 to 24 hours or even longer. And that's a long time to go between seeing a really detailed image that the polar orbiters are able to give us. And so the TROPICS is hoping to improve on that by being able to offer a microwave radiometer, which is already present on polar orbiting satellites, but on a small satellite that can actually give us a refresh rate for data of 30 to 40 minutes over any particular spot on the globe, or between 40 degrees north and south latitude.
I think I heard you before say that, was it NOAA that funded this project? Is that right?
NASA funded.
NASA funded. Okay. So my question was going to be, obviously right now, the trendy thing is private civilians going into space or launching space programs. Is this whole initiative public, private, or some combination of both?
This one is, I believe, wholly public. It started at MIT Lincoln Laboratory, which is, I believe, a government-funded lab, and it was also bankrolled by NASA. So I believe this is mostly public, and all of the data that they're collecting is going to be made public on NASA's archive website once they have the array up and running. Since
we were talking a little bit about the satellites' tech specs, I sort of have some questions along those lines here. For example, the imagery that we're going to get, I know this will vary depending upon the sensor type. So maybe I should back up and ask that question first. You know, what types of data are we going to get? Are we going to get visible imagery and typical infrared type and water vapor channels like we have with the GOES satellites and the polar orbiters, or is it going to be more the microwave type sensors that you were describing there?
This will just be the microwave type sensors. We won't get visual or infrared imagery from these. We will get 12 different channels of microwave channels from 90 to 205 gigahertz. So covering water vapor, covering temperature, and then some of those higher cloud tops that I was mentioning with the 205 gigahertz.
These satellites, you said they're more like the polar orbiting satellites. So how far up are the satellites, and at the altitude that they're orbiting, what are they? What's the resolution of the data that you're getting?
The TROPICS satellites are going to be orbiting at about 550 kilometers, so about 340 miles above the surface. So actually a little lower than our polar orbiters, but the resolution is going to be on par with the ATMS aboard the JPSS satellite. It's actually 16 to 24 kilometer resolution, depending on the wavelength. It's actually a little better resolution on temperature channels. It has a 25 kilometer resolution versus the 33 kilometer available on the ATMS. But on the rest of the channels, it's about on par with ATMS.
We are going to see the National Weather Service and the National Hurricane Center have access to all this data. Will the public have access to it as well?
Yes, they will. Anybody will be able to access the data on NASA's archive site. I believe that this will be made available next year once the entire array is loaded or is up in the atmosphere, but no concrete data on that, or no concrete answer on that yet.
I was just going to ask you, what are the benefits cost-wise to this type of project?
Yeah, that's a great question. And actually, one of the really interesting parts of this project that I found when researching it is that the cost benefit analysis compared to some of these bigger satellites, like our geostationary GOES satellites and our JPSS polar orbiters, which cost billions, take decades to kind of plan out and produce. The total price tag for the TROPICS array was 30 million to fully develop, and another 8 million to launch. So a much smaller price tag. Now, along with that does come the fact that these satellites are much smaller and they have a much shorter shelf life up in the atmosphere. So the mission length for this initial project is 1 year, but the crew is hoping that they can get a couple more years out of it. There's actually another array that was looking at wind speeds called Cygnus that was using tiny satellites that has been up there for 3 years. So there's definitely reason to believe that they could be up there for quite a few years and operational. But even if they did come down and NASA decided to continue the project, it costs about $1 million to produce a new one. So you could theoretically send an entirely new satellite array up there for $7 million to develop and another probably $7 million to launch.
Just based off of that, do you think nanosatellites are the future for weather technology?
I mean, I think they're definitely an interesting development and they could play a major part in the future of weather forecasting. I remember one really memorable thing that Bill Blackwell, the project lead of TROPICS, told me is that with the massive satellites that we typically put up, it takes so long to develop them that by the time they're in orbit, the technology on board is already 15 years old.
Right.
So it's like the Betamax of forecasting is how he put it. But with nanosatellites, we're able to get technology on board that's just been developed in the last couple of years and is the most current and capable technology that we have.
Their initial prototypes here have already yielded, I think, some positive signs for improving things like accuracy and intensity. Is that right?
Yeah, right. So before the qualification unit even launched, there were a few researchers at NOAA who tested out kind of how effective the extra data from TROPICS might be. They basically ran a simulation of a tropical cyclone and then sampled from the simulation the data that they would expect to get from the TROPICS satellites. And then they found that the forecast track actually improved by about 15%, and the intensity predictions improved by about 10%. They also found a consistent improvement in the temperature and wind forecast up to 5 days out, and also more accurate humidity forecasts up to 36 hours out. So very promising results early on. And of course, they'll need to look at the actual data once the full tropical satellite array gets up there, but really kind of interesting results that they're getting already.
Meghan, this is a really cool article, and we appreciate you coming on to tell us about it. I know you said you sought this one out because of your background in weather, your love for atmospheric science and space. Projects like this, I feel like, are coming up a bit more frequently, between getting the average person into space or increasing access to internet with space. I'm just curious to get your thoughts as a professional in this field about your thoughts on where all of this could be taking us in the next few years as this technology continues to develop.
I mean, I'm really excited kind of as a journalist who is covering space and satellites and weather. It seems kind of like a frontier right now with the technology that we're developing and that we're able to start launching, especially as launching technologies are getting a little bit cheaper, a little bit more economical. With SpaceX, I know that you can buy, space on a rocket and send your experiment up to orbit. And so hopefully we see kind of a democratization of who is able to send, their science project or experiment up to space and get answers. And I'm like really excited to be here to cover it all.
Can you give us just a tiny little insight into what your day-to-day is like as a journalist covering the space for an online publication and also a print publication?
Every day, kind of one of my favorite parts of the day is waking up and getting to see what all of the other editors at Wired are working on. Kind of have a group meeting where we go over everything that's being offered that day, which is always very inspiring because there's always so many quirky stories that everyone is publishing at Wired. But I will comb through a whole bunch of different sources on Twitter, at different universities. I often get a lot of press releases that I'm coming through to see, what is the next really interesting thing that I can cover. But I think my most exciting pitches and opportunities come through talking with people in these fields, because talking with someone usually like gleans a million different nuggets that you never would have gotten from a press release or something that you're just reading online. So it's definitely, that's a big part of my day. And then as a research editor, just making sure that everything that we publish is accurate and fact-checked, and devoting whatever time I can to looking up new science stories.
So if we want to learn more about technology, how can we do it?
You can follow me on Twitter at Meg E. Herbst. I'm also on Wired. You can just look up my author bio, and everything I published on the website will be under there.
Which part of it is the most fun? I mean, or more specifically, which story that you've done has been the most fun? Was it this one or some other story? And tell us about it.
This one was really fun. I think the most fun story I've written this past year was actually on the computer game Kerbal Space Program. I'm not sure if any of you are familiar with it.
No, but I'm listening.
It's a pretty old game. It's kind of over 10 years old at this point, and they're looking to come out with the Kerbal Space Program 2, but it's basically rocket science involving very tiny green creatures called Kerbals. You get to design and launch your own rockets and try to get into orbit and try to reach other planets, and it's all using like rocket science concepts and basically teaching you while you're also kind of sending these little green creatures either to their death or to the moon. But I was writing a story on these really cool modders that have popped up in the Kerbal Space Program community who made next gen space engines using fusion technology and fission, antimatter rockets, all that kind of stuff. And it was really fun to kind of get into the science behind how those would actually operate.
So you live in the Bay Area, California. What's that like in general? You've lived in other parts of the country, so compare and contrast.
I've lived in the Bay Area for about, I want to say 6 years now. And I actually really love it here. It's got a very vibrant, diverse culture. It can definitely be very crowded. And I'm not so used to city life, hailing from Virginia, kind of Northern Virginia area myself. But I love the weather and just how much there is to do around here and see. And yeah, I haven't gotten tired of California yet. So
someone who's visiting your area, what's something you've got to do? I
would definitely recommend going to Golden Gate Park in San Francisco. It's got the California Academy of Sciences, the DeYoung Museum of Art. It's got this gorgeous park with a lot of beautiful architecture and gardens. That's like one of the first places that I take anybody who's coming out to visit. We just spend a day there touring the museum and like these big sprawling botanical gardens. Yeah, that's definitely the thing I would recommend most.
Favorite restaurant?
There's, I'm out in the East Bay, so I have an East Bay restaurant that's kind of my favorite. But there's this really gorgeous kind of older style Italian restaurant in Orinda, California, which is a little bit east of Oakland. It's just got all of the Italian classics and just like a really authentic feel in there, frescoes on the walls and everything. And it just like great customer service and always really delicious.
Have you visited the Carolinas before?
I have, yes. My sister actually lives in Raleigh. And, I'm from Virginia, so I spent plenty of time driving, up and down the southern coast there to go visit family in Florida. Even had some family in North Carolina for a while, and now obviously my sister. So,
okay. Well, so what's your favorite spot in the Carolinas?
My cousin actually got married in Charleston a couple of years ago, and Charleston's pretty beautiful. I know that must be a cliched place to say is your favorite spot in the Carolinas, but
yeah, add another vote for Charleston.
I'm just thinking here. I think every guest we have outside of North and South Carolina, Charleston is somehow, some way always mentioned. So
right.
It is what it is.
It's not a bad spot. I don't know why we're.
No, it's not a bad spot. No, not at all. But Charleston should give us some kind of props here. We keep talking about them all the time.
The Charleston Chamber of Commerce needs to recognize us.
Right. That's right. They should cut you a check of some sort.
I don't know if we're doing any more than Travel and Leisure magazine hasn't already done by constantly naming them like the most popular, beautiful place to visit. So
yes, yeah. We'll chalk another one up for Charleston.
Yeah.
All right, that's all I got, guys.
We certainly appreciate this. We're anxiously awaiting the launch in 2022. So maybe closer to that, maybe we can do a follow-up with you and kind of see how that goes. But until then, we hope you have a great night. We appreciate your time, and we appreciate all of you who are watching and listening to us on the Carolina Weather Group. Make sure you press that subscribe button if you've not already on your favorite podcast platform. I think we're on all of them now, aren't we, James? You just type Carolina Weather Group and you can find us. So subscribe to us. We'd love that. Visit the Patreon page. What else am I missing, James? You do this way better than I do.
I could do this for 10 minutes, but if you follow us on Spotify, be sure to scroll back through, look for the episodes with the little music notes, and revisit our summer panelist playlist series where these guys introduce you to some of their favorite musical stylings and their own personal weather stories. That is a feature you can only find on the Carolina Weather Group's Spotify feed.
All right, so be looking for that. So thank you again for watching and listening to us. We'll see you next time.